Okay, everyone, let's talk about expected value. Okay, I highly, highly encourage you to go to your textbook and read page 772. It does a great description and explanation of what expected value is. For this video, we're just going to kind of jump into the what, the how, the why. Okay, but the explanation and the lead up to all this is really fantastic in your book, so I encourage you to go and read it. Okay, so in short, expected value is a mathematical way to use probabilities to determine what to expect in various situations. This is quite literally the definition of expected value. It's a way to take outcomes and probabilities and use those to figure out what to use in the long run. This is really common for insurance companies. They use expected value to determine what to charge for different policies. This could be used in games of chance. This could be used for like realtors and contractors when they're debating on whether or not to take a house on or to take a building contract on. They can use expected value. Expected value is not a sure thing, but it's what to expect in the long run. And I do want to highlight over the long run. That's a huge part of expected value. Okay. Now, the standard way to calculate this, I'm going to put it right here. So to calculate, multiply outcomes by their probability. And then add them up. Okay, that is the standard way to calculate expected value. No matter what you're looking at, you're going to have particular outcomes. Okay, each outcome is going to have a predicted probability. Okay, and then you take the outcome, you take the probability, you multiply them, and then you add them all up. Okay, and that's exactly what this formula is saying. Now, I fully expect you to look at this formula and be like, what? Okay, yes, there's some weird stuff happening in this formula, but it's fairly easy to understand once I explain it. So we have this symbol right here. This is a summation symbol. And in math, it literally translates to add them up. Okay, so you look at whatever comes after the summation symbol and perform that and then add them up. In this case, X is the outcomes. Okay, and then P of X is the probability of the outcome. So this formula E is expected value, and then it says add up each outcome times its probability. So you literally take the outcome, multiply it by its probability, and add them up. Okay. So the reason I show you this formula here is you'll see something similar to it when we look at our chapter on statistics. Okay. Now, the first example we're going to look at is very theoretical. What I want you to remember is when we're talking about expected value, we're looking at what happens on over the long run. So it's kind of like, on average, what could you expect if you did this over and over and over again? So our first example is to find the expected value for the outcome of the roll of a single die. Okay, well, if we were to look at this, the outcomes would be 1, 2, 3, 4, 5, or 6. If you have a fair standard six-sided die, the sides that you could potentially land on would have 1 dot, 2 dots, 3 dots, 4 dots, 5 dots, or 6 dots. Those would be our outcomes. The probabilities would be 1/6 each. All right, the chance of landing on the side with 1 dot is 1/6. The probability of landing on a side with 4 dots is 1/6. So the probability of each individual outcome is 1/6. So to calculate the expected value, we would take each individual outcome, multiply it by its probability, whoops, let me make that look like the others. And then from here, you can clean it up a little bit, or you can go to your calculator. This one's pretty easy to do the calculation by hand, so let's do that. 1 times 1/6 is just a sixth. Then we get 2/6, 3/6, 4/6, 5/6, and 6/6. And hopefully you remember from long ago, when you're adding fractions, as long as the denominator is the same, you just add up your numerators. So if we look at just the numerators and add those, we get 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21. So we get 21 over 6, or 3.5. So this right here, let me do it in another color so you can see it better. This 3.5 right here is the expected value, okay? So what this means is if you rolled a die over and over and recorded the outcome, that's not how you spell outcome, and recorded the outcome. So basically the outcome being what does the die land on each time you roll it. So you roll a die over and over and over and over and over, and every time you roll it, you record what it lands on. The average of the outcomes would be approximately 3.5. Now, all of us know that we don't have a side of a die that has 3.5 dots on it. We're just saying in the long run, if you did this over and over and over and over and recorded your outcomes, the average outcome would be approximately 3.5. Okay, so that's a very theoretical example of expected value. I like to show it because it showcases the formula very, very nicely. Okay, for the rest of the examples that we're going to look at stuff that is more like real world applications. Okay, so there you have that. Let me see if I can. I'm going to stop share and then share again to see if I got rid of all of my writings to save myself the hassle. There we go. All right, so from now on, the examples that we're going to look at are going to be much more realistic. So the first example is insurance claims. The second example is a contractor bidding on a job. The third example is a game of chance. And then I want to say the examples after that are also games of chance. Okay, so for the next two examples, I'm going to give us a little space here. There we go. All right, so for the next two examples, the first one we're going to look at is an automobile insurance company, okay? So an automobile insurance company has determined the probabilities for various claim amounts for drivers ages 16 through 21. So these are our younger drivers. We would expect probably more accidents, more payouts potentially. This is all shown in the table below. Calculate the expected value and describe what this means. Well, we have claim amounts. Those are the outcomes. We could expect claim amounts of $0, $2,000, $4,000, $6,000, $8,000, or $10,000. And then the corresponding probabilities are in the next column. So I do want to just showcase this is the outcome. Okay, the probability for a claim of $0 is 70%. So keep in mind, we're dealing with the probabilities in decimal form. Just know that 0.7 would translate to 70%, 0.15 is 15%, 0.08 is 8%, 0.05 is 5%, 0.01 is 1%. So if we were going to calculate the expected value, we would take each claim amount, so $0 times 0.7, $2,000 times 0.15, $4,000 times 0.08, $6,000 times 0.05, $8,000 times 0.01, and $10,000 times 0.01. Now, I would go to a calculator from here, so let's see what we can do. Make sure you have that written down before we go to the calculator. Is it this one? So this is my easy access online calculator. Okay, so right here, what we're going to do is we're going to take each claim amount, multiply it by its probability. So we had 0 times 0.7. We had 2,000 times 0.15. We had 4,000 times 0.08, 6,000 times 0.05, 8,000 times 0.01, and then finally we had 10,000 times 0.01. Let me double check and make sure I didn't make any mistakes. Okay, so 0 times 0.07, 2,000 times 0.15, 4,000 times 0.08, 6,000 times 0.05, 8,000 times 0.01, 10,000 times 0.01, and we finally get an expected value of $1,100, okay? So let's go back to our document. All right, so we have an expected value of $1,100, okay? This means, on average, if you had thousands of these drivers report claims, thousands and thousands of them, and you recorded the payout every single time, on average, the payout would be approximately $10,000. Okay, so what does this mean? This means if you charge 1,100, I think I said 11,000 a minute ago. I meant 1,100. If you charge $1,100, you would potentially break even. Now, this does not mean if you charge $1,100, you are going to exactly break even. This is all kind of like a game of chance. We're taking these probabilities. It doesn't mean the probability of a $0 claim is exactly 70%. It just means looking at the history of these drivers and looking at payouts over years and years and years of research and of data, we could expect that the payout of $0 has a probability of 70%. It doesn't mean that with this particular policy, you're going to have exactly 70%, but it does seem very likely because, again, they pay people to look at data for years and years and years and years. Okay. Now, on average, if you have these payouts with these probabilities, you could expect to pay out $1,100. That means every single person that gets a policy doesn't get $1,100. Okay. It just means on average for everybody that has this policy, each person would get on average $1,100. A lot of those people are going to get $0. Some of those people are actually going to get lots of money, like $8,000 or $10,000. But if we took the payout for everybody and split it amongst everybody, on average, people would be getting $1,100. Again, some people wouldn't get that at all. Some people would get much more. It's just the average payout. Now, if you charge $1,100 for this policy, you would potentially break even. To make a profit, you would want to charge more. Well, that's not good. More than $1,100. Okay. So again, they're going to say, let's say they have 500,000 people that bought this policy. Okay. They would expect to pay out $1,100 for each of those people that bought this policy. That doesn't mean each person gets that payout. That would just be the average payout based on how many people have the policy. Okay. So if they want to make a profit, they're going to charge more than $1,100 per person. If they want to break even, they're going to charge $1,100. Okay. Again, this is all kind of a game of chance. It's all what you could expect over the long run. Okay. Now, the next example, a contractor is planning to bid on a new building. Okay. The cost to draw up plans and submit the bid is $10,000. The probability of landing the bid is 10%. Okay. So 0.1. All right. And the earnings would be $100,000. What is the expected value for landing the bid? Now, here's the deal. With the previous example, we have these payout claims and their corresponding probability. In this particular case, we have a situation where there's a gain or loss associated. So we have to approach this one a little different. Okay, so we're going to create a table. We have the different outcomes. So the outcome is you get the bid or you lose the bid. Those are your two possible outcomes. You either get the bid or you don't. All right. But now each of these outcomes has an associated gain or loss. Okay. Now we know that if you get the bid, you would earn $100,000. But remember, you had to pay $10,000 right here just to draw up plans and submit your bid. So if you had the potential earnings of $100,000, but you paid $10,000 to kind of play the game, your gain would be $90,000. Okay, that's assuming you get the bid. Now, there's also that chance that you don't get the bid. Okay, if you don't get the bid, your gain is $0. But remember, you paid $10,000 to draw up plans and submit the bid. So in this case, your loss would be the $10,000 that you paid. Okay, now the third thing we would have to consider is the probability. We are told flat out that the probability of winning the bid is 10%. So then you're kind of like, well, what would the bid be, or what would the probability be if I don't get the bid? Well, the probabilities would have to add up to 100%. If we go back to this previous example over here, if we go right here, okay, those probabilities add up to 100%. So when you're dealing with expected value, all of the different probabilities have to add up to 100% or to 1. Well, if the probability of getting the bid in this case is 0.1, the probability of not getting the bid is a whopping 0.9. Okay, so you may have to do a little math on your probabilities depending on what the situation is. Now, if we were to calculate the expected value, the gain for getting the bid is $90,000. And there's a probability of 0.1. Okay. Now, the loss associated with not getting the bid is negative 10,000. So I would just write minus instead of plus. So minus 10,000. And then I would multiply it by its probability. Okay. So let's go to the calculator again. All right, so we had a 90,000 gain if we get the bid, and it's in its probability is 0.1. We have a loss of $10,000 if we don't get the bid. Its probability is 0.9. So the overall expected value here would be $0. All right, so let's look at what that means. All right, so the expected value here is $0. So that means there's not really a huge risk one way or the other. If you get the bid, don't get the bid, you know, the outcome, if you did this over and over and over and over, let's say you had similar bids and you've done dozens and dozens and dozens of these over the years, and you calculate your earnings and your losses, you'd end up with an expected value of $0. So what a lot of contractors will do is they'll have an expected value in their mind. They'll say, I'm not going to take the bid or even worry about bidding on this building or this project unless the expected value is $10,000 or the expected value is $8,000. So in a situation like this one seems fairly risky. They may not take this bid. So again, a lot of times with a contractor, they'll have a bid or they'll have an expected value in mind. Again, I'm not even going to bid on it unless the expected value is X dollars. So then that way, if the expected value is less than that, they'll be like, I'm not even going to worry about bidding on it. If it's more than that, they'll be like, you know what, that seems pretty realistic. That seems reasonable. I'll go ahead and bid on that job. So that's how expected value works for a situation where you have like a contractor or a realtor. They'll have an expected value in mind. If the expected value for a particular situation is greater than that, they would take the job or they would bid. If it's less than the particular expected value, they probably wouldn't waste their time bidding on it. All right. So this one seems maybe potentially risky. It just depends on what that particular contractor has in mind. Okay. So let's go. We're going to stop share. It's just easier for me to stop share and then go back to the worksheet than trying to erase it all. There. Oh, it didn't do it this time. Well, let me stop share again. Okay, so next up, let me go back to the worksheet. I was able to move it nicely this time. Okay, so next up, we're going to talk about games of chance. And some of my favorite situations here are raffles. Okay, so keep that in mind. I do love a raffle problem. Okay, if we were having our normal in-class test, you could pretty much guarantee a raffle problem would be on there. Okay, so let's look at this raffle problem. This one says a charity is holding a raffle and sells 1,000 raffle tickets for $2 each. One of the tickets will be selected to win that should say grand prize. Pardon me, let me fix it right now. Is selected to win a grand prize of $1,000. 2 other tickets will be selected to win consolation prizes of $50 each. Find the expected value if you buy 1 raffle ticket. Describe what this means in practical terms. And then what could you expect to happen if you purchase 5 tickets? Okay. So, first of all, what kind of charity raffle is going to give away over half of their earnings? I have no idea, but let's just say that the grand prize is $1,000, consolation prizes are $50, and let me hydrate. Let's get to it. So this is going to be sort of similar to that bid situation, the contractor bidding on a job, in the sense that there's a gain and a loss. There are 3 different outcomes here. You win the grand prize, you win a consolation prize, or you win nothing at all. Okay. And with each of those, there's an associated gain or loss. Now, for this example, we're going to be buying just 1 ticket. So we're going to look at 1 ticket first. Okay. Now, the cost of a ticket is $2. Okay. So if you buy a ticket, it's going to cost you $2 no matter what. Now, if you win the grand prize, you're going to win $1,000, but don't forget you paid $2 for your ticket. So that means your gain here is really only $998. Now, if you win one of the consolation prizes, you win $50, but just like the previous example, you had to buy your ticket. So you still paid $2. So your associated gain or loss here would just be $48. Now, if you win nothing, you truly win nothing. You win $0, but you still paid to play. So we have an associated loss of $2 here. Okay. Now for the probabilities. We know there were 1,000 raffle tickets. Okay. 1 of those tickets will be selected for the grand prize. So the probability of winning the grand prize is 1 out of 1,000. Okay. Now we know 2 of the tickets will be selected for the consolation prize. Okay. So that means the probability is 2 out of 1,000. Now all of the remaining tickets win nothing. So of the 1,000 tickets, 3 of them have potential winnings. The other 997 tickets have no winning associated with them. So the probability of just winning nothing or flat out losing would be 997 out of 1,000. Okay. So the expected value here, we would take each outcome. That's going to be your gain or your loss. So we have a gain of $998 with a corresponding probability of 1 out of 1,000. We have a gain of $48 with a probability of 2 out of 1,000. We have a loss of $2 with a corresponding probability of 997 out of 1,000. So let's go to the calculator and see what we can come up with for our expected value. Okay, so again, we had $998 with a probability of 1 over 1,000. We had winnings of $48 with a probability of 2 over 1,000. And then we had the situation where we win nothing. So that's got a gain or a loss, the loss in this case of $2 with a probability of 997 over 1,000. So we have an expected value of negative 0.9. So let's go back to the worksheet and discuss what that means. Okay, so we have an expected value of negative 0.9. That means if you played, or let's not say played. How do I erase on this one? I have no idea how to erase on this one. So yeah, I do. I lied. So if you bought tickets for similar raffles over and over and recorded your winnings, you would lose 90 cents on average. Now, that does not mean you lose 90 cents every time you play a raffle like this. Sometimes you're going to win grand prizes, sometimes you're going to win consolation prizes, most of the time you're going to lose. Okay? That just means if you were to play this over and over and over and over and over and over hundreds of times and you recorded your gains and your losses, on average you could expect to lose 90 cents every time you play. Now, with that said, it's generally for charity. Suck it up, lose your $90 or your 90 cents, okay? But that is what you could expect over the long run, okay? Now, just to flip things around, the question then says, what would we expect if we bought one raffle ticket? So if we were to purchase one raffle ticket, we could expect to lose 90 cents every time we played. Okay. Again, that doesn't mean you actually lose 90 cents. It just means on average, you're going to lose 90 cents every time you play. The question then goes on to say, what would happen if you purchased 5 tickets? So let's look to see what happens if we purchase 5 tickets. Okay. So I'm going to erase the table a little bit because we're going to have to fill it in and change it. Now, the probability does not change. Out of the 1,000 tickets, there's still only one grand prize. There are still only 2 consolation prizes. There are still 997 tickets that win nothing. Okay. What's going to change here if we buy 1 ticket versus 5 tickets is the gain or the loss. Okay. So now let's look at what happens if we buy 5 tickets. All right. So if we were to win the grand prize, remember, our winnings would be $1,000. But we bought 5 tickets at $2 each. So it cost us $10 to play this time. That means our actual winnings would only be $9.90. Okay. Now for the grand or the consolation prize, you would win $50. But again, you bought 5 tickets at $2 each. So we paid basically $10 to play. That means our gain would only be $40. If you were to win nothing, again, you're going to win $0. But remember, you still bought 5 tickets at $2 each. So you have a loss of $10 now. Okay. So the expected value for 5 tickets, okay, we have $9.90 times 1 over 1,000 plus 40 times 2 over 1,000 minus 10 times 997 over 1,000. So let's go to the calculator and see what happens here. So when we go to the calculator, all right, we can go back up here to this previous example. Instead of retyping the whole thing, you can go to this previous one and then just hit enter. And then you can go and type over. So instead of 998, we win 990. Instead of 48, we win 40. Instead of $2, we lose $10. All of the probabilities are exactly the same. So all I did was just redo the problem and all I changed were the gains and losses and then hit enter. And if we were to play with 5 tickets instead of 1, our gain or loss would be negative 890. So let's go back to the worksheet and see what that means. So we have an expected value of negative $8.90. So similarly, if you were to play a raffle like this over and over and over and over and over and over, and you recorded your gains and your losses, and then you average that out, on average, you could expect to lose $8.90 every time you buy groups of 5 tickets. That doesn't mean you lose $8.90 every single time. Sometimes you're going to win the grand prize. Sometimes you're going to win the consolation prize. Most of the time, you're going to win nothing. But on average, your earnings would average out to be approximately a loss of $8.90 every time you play. Okay? All right. Do we want to do both of these? Let's definitely do this second one. Okay? So the next example is kind of another game of chance. All right. And you should be semi-familiar with Keno if you've ever watched the National Lampoon's Vegas Vacation. They play Keno at the end. But anyway, if you don't know what that is, don't worry about it. So in the game of one spot Keno, a card is purchased for $1. So you're buying a card for $1. It allows a player to choose one number from 1 to 80. A dealer then chooses 20 numbers at random. If the player's number, that should not say amount, is among Whoops. All right. So if the player's number is among those chosen, the player is paid $3.20, but does not get to keep the dollar that they paid to play. So you lose the dollar no matter what. Find the expected value of a $1 bet. Describe what this means. Okay. So let's make a table. So we have the outcome, we have the gain or loss, and then we have the probability. Those are kind of the basics to these tables. So be prepared to create some of these in your homework, okay? Now, the gain or loss here is going to be associated with two outcomes. Your number is one of those chosen or it is not. So we have number chosen or number not chosen. Those are the two outcomes here, okay? Now, remember, you paid $1 to play. If your number is one of those chosen by the dealer, you win $3.20. But remember, you paid $1 to play, so your gain would be $2.20. Okay. If your number is not chosen, you don't win anything, but you still paid $1 to play, so your loss is $1. My dog is in here if you hear her. Winnie, you want to say hello? You want to say hi? You don't want to say hi? You don't feel like doing math today? You're a sweet girl. Okay, so we've got the outcome, the gain or the loss. Now we need to talk probability, okay? There are numbers 1 through 80, so that means there's 80 possibilities. Your number is chosen, that means it's one of those 20 out of 80 that the dealer chose. So the probability that your number is chosen is 20 out of 80, okay? Now, for your number not to be chosen, it's one of the 60 numbers not chosen, so 60 out of 80. So we have 60 out of 80. And remember what I told you earlier is your probabilities are always going to add up to 100 or to 1. If we take 20 over 80 and we add 60 over 80, we get 100% or 1. Okay? So the expected value here would be $2.20 times 20 over 80. Or we lose, so that's going to be minus 1 times 60 over 80. Let's scoot over to the calculator to see what our expected value would be. So we have $2.20 times 20 over 80. Or we have a loss of $1 with a probability of 60 over 80. So you want it to look like this. All right. Hit enter, and we get negative 0.2. Let's go to the worksheet to figure out what that means. All right. The expected value is negative 0.20. That means if you were to play this one spot Keno over and over and over and over and record your winnings, you could expect to lose approximately 20 cents every time you play. So you could expect to lose 20 cents every time you play over the long run. All right. This doesn't mean you lose 20 cents every time you play. You're either gaining $2.20 or you're losing $1. But if you did this over and over and over and over and over and you average those gains and losses, it levels out to be a base. I can't even talk. It levels out to be basically a loss of about 20 cents every time you play. Okay, so there you have that. The last example, we're dealing with a spinner on a wheel of fortune. So let's go ahead and do this last one just for the sake of, let's call it fun, okay? The spinner on a wheel of fortune can land with an equal chance on any of one of 10 regions. So there's 10 different regions. Keep that in mind. That'll be important for the probabilities. 3 regions are red, okay? 4 are blue, 2 are yellow, 1 is green. A player wins $4 if the spinner stops on red, $2 if it stops on green, and the player loses $2 if it stops on blue and loses $3 if it stops on yellow. What is the expected value? Well, let's create our table. We have the outcome, the gain or loss, and then we have the probability. Okay. As far as the outcomes, you can land on red, blue, yellow, or green. let's do the probability next, okay? If you land on red, the probability of that happening is 3 out of 10. There are 3 red regions out of 10 total, so the probability of that is 3/10. 4 of the 10 regions are blue, so that would be 4/10 landing on blue. 2 are yellow, so 2/10 is the probability for landing on yellow, and 1/10 is the probability of landing on green. Now, if you add up these probabilities, 3 plus 4 is 7, plus 2 is 9, plus 1 is 10, 10 out of 10 is 1. Remember, the probabilities are always going to add up to 1 or 100%, okay? Now let's talk gain or loss, okay? A player wins $4 if the spinner stops on red. So they win $4 if it stops on red. They win $2 if it stops on green. All right. The player loses $2 if it stops on blue. And they lose $3 if it stops on yellow. Now, you don't have to pay. It's not like you're paying to buy a ticket. You either win money or you lose money depending on where you land, okay? So the gains and losses are pretty straightforward in this situation. Now, the expected value, if we land on red, we win $4. The probability is 3/10. If we land on blue, we lose $2. Probability is 4/10. If we land on yellow, we lose $3. The probability is 2/10. And if we land on green, we win $2. The probability there is 1/10. Okay. Now we would want to go to the calculator. We can do this one kind of in our head. This one's going to be fairly easy. So we would get 12/10 minus 8/10 minus 6/10 plus 2/10. And then 12 minus 8 minus 6 plus 2 over 10. So 12 minus 8 is 4, minus 6 is -2, plus 2 is 0. So the expected value here is 0. That means if you were to play this game over and over and over and over and over and record your winnings, you would break even, okay? That doesn't mean every single time you break even or you win nothing. It means that a lot of times you're going to win $4 and you're going to lose $2, you're going to lose $3, you're going to win $2. You're going to have a broad range of winnings and losses here, but over the long run, if you were to average out those earnings, you would end up with an expected value of $0. So there's not a huge risk to play this particular game. Okay, so that is expected value. Again, I do highly encourage you to read your textbook on this. Your textbook is good in a lot of areas, and this is one of the areas that it's really quite good at. So please read your book on expected value. Watch this video as many times as you need to. Remember, you can start, stop, pause, rewind, whatever. But there you have it. So that's your video for expected value. All right. Hope y'all are doing good.